If you've taken any intro to linear algebra course, then you've most likely dealt with matrix multiplication, as it's a very handy operation. And we're going to use it quite often in the neural networks section, so I'll cover it very briefly. Suppose we had a matrix A and a matrix B. Then the product of matrices A and B is defined only if the number of columns in matrix A equals the number of rows in matrix B, which is exactly the case, since matrix A has 3 columns and matrix B has 3 rows. And so, given that the condition is satisfied, the way this would occur is you multiply the numbers in the first row of matrix A with the numbers in the first column of matrix B. 0 times 3, 3 times 3, and 5 times 4, giving you 0, 9, and 20. Take their combination to obtain 29. We do the same thing but now for the second column of matrix B, to obtain 0, -6, and -10, resulting in a value of -16 when taking our sum. Alright, now we're done with the first row. We do the same exact thing for the second row. But now restart at the first column of matrix B, 5 times 3 plus 5 times 3 plus 2 times 4, which equals 38. And now the second column, 5 times 4 plus 5 times -2 plus 2 times -2, which ends up equaling 6. And that is all. We've taken the product of two matrices, and let's do this in our code really quickly. First, we start by importing torch, import torch, and then on the next cell, we start by defining a matrix, matrix A, is equal to torch.tensor, containing the same values of the matrix that we talked about earlier, 0, 3, 5, 5, 5, and 2, and this tensor will be viewed to be, or to have, 2 rows and 3 columns as we had earlier. Outputting this matrix A, and now on a different cell, we'll define another matrix, matrix B, which will be set equal to torch.tensor, and again the same values as before, 3, 4, 3, -2, 4, -2, but this will be reshaped.view to have 3 rows and 2 columns. Outputting this matrix B, we get the following, which is what we expect, and now we can conduct matrix multiplication between the two by writing torch.matmul. We will matrix multiply matrix A and matrix B, and this should yield the expected result. Another way to perform the same operation is to simply write matrix A at matrix B, yielding the same result. That is all. In the next video, let us talk about derivatives and how differentiation is performed with PyTorch.